So let's learn something new. We're going to do solving quadratic systems, and you can see there are quadratic systems with anywhere from no solutions to 4 solutions. I can think of plenty other ones. I could probably do a circle with a parabola that would have 1 solution. So obviously there are plenty other ways to do these. Okay, so just like in other systems, there are 3 ways to solve these: graphing, substitution, elimination. We're going to start with graphing. So I'm going to pause and I'm going to complete the square and find 4p. And because we know by looking at this, this would be a parabola and this is a line. So I'm going to pause and get them set for graphing. So if I were to graph this, I can see the line is easy. I'm going to be at -3. I'm going to do a slope of 2. And now I'm going to graph the quadratic. It obviously has a vertex at 3/7, 0, and p is 7/4. Obviously, my solutions are where they intersect, because the solution to a system is where 2 functions are equal, and so they're going to intersect somewhere right here, and they're going to intersect somewhere right here. And graphing and doing this with my eyes on a piece of graph paper isn't going to work. So what we're going to do is we're going to put them in the calculator. Now, the first thing you need to realize is we're going to solve both of them for y, and I already have one. The other one is going to be y squared equals 7x minus 3. I'm going to take the square root, and I'm going to get y equals the square root of 7x minus 3. Y equals the opposite of the square root of 7x minus 3. And lastly, the line. I'm going to go ahead and put these in y1, y2, and y3. This is the graph that I will get, so you can see where our 2 intersection points are. The thing you have to be careful of is I now have 3 graphs in. I have the positive square root, the negative square root, and the line. One intersection is on the positive square root and the line. One intersection is on the negative square root and the line. So I'm going to have to calculate 2 intersections separate times, and I have to be careful when I choose the first curve and choose the second curve. We're used to, in algebra, just pressing enter, 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 because there's only 2 curves, and the intersection is 1 intersection. It's a little bit more tricky now, so just take your time. So the first intersection I get here would be 4, 5. And the second intersection I get is 3/4, -3/2. Let's try that again. 3/4, -3/2. So it's solved by substitution. Same thing as we've always done substitution. Y equals this right here. So I'm going to substitute that in for y here with parentheses. So I get x squared plus, and I'm going to put my y in now, squared equals 10. And I'm going to have to distribute out the binomial. So if you remember the shortcut, it's square the first, multiply them in doubles, so that's -30 doubled, and square the last. And that's going to equal 10. I'm going to combine like terms. I'm going to take out a 10. And I'm going to factor this as x minus 3 quantity squared, which means my solution is x equals 3. We all know that the solution to a system is an ordered pair where they intersect. Well, now I know there's only one x. So I'm going to plug the x into here, where the y is, so I get y equals -3. Plug in that 3. Plus 10 and I get the answer of 3, 1. Now, if I substitute those both into the equation, if I substitute this x and this y into both equations, it should work for both equations because this is where the graphs are equal. So if I do x squared plus y squared, does that equal 10? Yes. And does 1 equal negative 3 times 3 plus 10? Yes, so it checks out. Lastly, let's look at an elimination. I'm trying to keep this video short, so I'm just going to give you one of each example, graphing, substitution, and elimination, and then in class tomorrow you will go ahead and do your practice. So I need to eliminate, and I need to eliminate every x term or every y term. And I see here that I forgot the squared on this equation, so this should be a squared right here, and that is terrible. Let's try that again. And this should be a squared, and this should be a squared. Sorry about that. So I need to eliminate all my x's or all my y's, and I can see if I multiply this top equation by a negative 1, what I'm going to have is negative 16x squared minus y squared plus 24y minus 80 equals 0. And I now can add those together, and my 16x squares cancel. I'm left with 24y squared plus 24y minus 480. I'm going to factor out a 24. And I'm going to factor this quadratic to y plus 5, y minus 4. So my solutions are going to be y equals 5, negative 5, and y equals 4, which means I'm going to have to plug in 5, negative 5 first, and positive 4 second. So if I plug in negative 5 first, I will get 16x squared plus negative 5 squared minus 24, plug in negative 5, plus 80 equals 0. And I'm going to end up with 16x squared plus 225 equals 0. And I know as soon as I subtract this 225 across, my answer is going to be imaginary. So there is no solution, or there are imaginary solutions when I plug in the negative 5. So now let's plug in the negative 4, positive 4. So I get 16x squared, and it doesn't matter which one I plug in, plus 25 times 4 squared minus 400. I get 16x squared equals 0 because these add together to 0. So x equals 0. So now be careful when you put this in. The x is 0, the y is 4. There is no ordered pair with 5. So what I would do now is store store 0 as x, and I would store 4 as y, and I would then type in my equations and see if the results gave me 0.